Okay, so let's keep talking about classification. So again, remember in the previous lectures or previous parts, we were discussing how we identify life, how we organize life, the different systems and then methods and lines of evidence used to help really organize life into these different groups. Well, classification is placing those species and higher groups into the taxonomic hierarchies. As I mentioned before, kingdom, domain, kingdom, phylum, etc. We'll revisit that a little bit later. Right now, what I want to talk about is kind of how we can group different species, or maybe talk about grouping families or classes or etceteras within classification. So we typically will break things up into three different groups. There's a monophyletic, paraphyletic, and polyphyletic grouping. Now these are just organizational terms and ways of organizing different categories. It's not a classification level. So you wouldn't see domain, kingdom, phylum, monophyletic grouping. That's not how this is used. This is more just for an organizational purpose. But it's important to have a little bit of a background, because when we're talking about different groups and we're comparing groups, this species against this species, it's important to know, are they a monophyletic group versus paraphyletic versus polyphyletic. So let's start with monophyletic. The monophyletic grouping is a recent, make sure I can spell this right, recent common ancestor and all of, I'm going to put that in uppercase or capitals. Oh, and all of its descendants. Okay, so basically a clade. This is what we can call a monophyletic group. And I'm going to show you an example in just a few minutes here. Paraphyletic is the recent common ancestor that we're looking at, but not all of its descendants. All right, so monophyletic is basically grandma, grandpa, and everybody related to them. Paraphyletic, grandma or grandpa, but you're kicking out your Uncle George because for whatever reason. It's not all of them. The polyphyletic grouping is when we take a look at grouping of species or classes or whatever, and it does not include the most okay, so polyphyletic is basically just a collection of different species you want to look at. There is some relatedness, but you may have to wiggle back quite a ways to get that relatedness, and it isn't necessarily going to include all of the members of the group. So this is you, a cousin, an uncle, but a friend, or a second cousin, or a fourth cousin, that type of thing. All right, so when you're looking at different groups of organisms, you want to understand how are they grouped. And when they're presented, or when it's presented in a taxonomic tree, it should tell you what type of grouping that you're looking at. All right, so here's an example of the different ways we could group these things and organize these things. All right, so let me get the pen out. All right, so this is a monophyletic grouping when we use this grouping called, or this term called archosaurs. So this is taking crocodiles, basically everybody in here. Crocodiles, stegosaurs, tyrannosaurs, velociraptor, and hawks are all grouped together as a monophyletic group. We're kicking out turtles and bats and giraffes because what we're doing is going from this common ancestor up this side and up to here within this phylogenetic tree. We're not including turtles, bats, or giraffes because we don't want to come down to this common ancestor down here. So we're not wanting to reach down there, we're wanting to stay right here, and we're wanting to study these animals and how they relate to each other as a monophyletic group. All right, so just one way of organizing. Now let's take those same animals, same list, and let's group them differently. Okay, this is the grouping, the paraphyletic group. We're using this common ancestor, but you notice we've kicked out two things, two groups. We're not including the hawk. That group's out. And we didn't dip down here to include the crocodile. So we stopped right here at this common ancestor. So because we're using this common ancestor and going up here to include stegosaur, tyrannosaur, velociraptor, but we're kicking out hawks, we would then classify this as a paraphyletic group. So we'd say, oh, let's talk about dinosaurs. That's why birds are not in that category, because they're not considered a dinosaur. But if we go back one to the archosaurs, then birds and crocodiles would be discussed along with all of those other things we generically call dinosaurs. Right? So paraphyletic. Now, the third type, the polyphyletic, is this one. This is just one example, where we'd say, okay, what are we interested in looking at? Well, let's look at flying vertebrates, any vertebrate that flies. Well, we got bats right here and hawks over here. We're not going to include any of these. We're ignoring those. We're kind of, in a sense, kicking those guys out to just focus on the flying vertebrates. So we'd study them as a polyphyletic group because we're not going all the way down to the common ancestor. So think about it, you'd have to dip all the way down here to get to the common ancestor of bats and birds. But if you're going to go to this common ancestor, that's CA for common ancestor, then you'd have to include all of these species or groups within your study or your discussion. So three groupings, three ways of kind of organizing things based on how you want to study it. There's no right, wrong. It's just when you're studying things like this, be very upfront about this is how I'm organizing it in this manner, in this fashion. And I am studying these things as a monophyletic group or a paraphyletic or etc. So, okay. All right. So kind of wanting to give you guys a feel for organization, classification, systematics, all those things. What we want to look at now is a little bit of comparative biology. How do we use this field to help organize and classify and arrange species? So with comparative biology, we often use what we call homologous structures to show and support relatedness. So take these organisms, bats, humans, horses, porpoises, we all share the same bone pattern. Humerus is our upper arm bone, then you have a radius and the ulna, then you have carpals, metacarpals, and phalanges. Well, so do all these other animals. Same bone pattern, different sizes, different thicknesses, different fusion of bones, etc., but the exact same bone pattern. This leads us to believe all four of us, bats, humans, horses, porpoises, had a common ancestor way back when, a long time ago. So that's what we often use comparative biology for, is to understand ancestral relatedness. And when is a new characteristics showing up in what group versus is this an ancestral trait? So back to our dinosaurs for a moment, because they are a really fun group to study and look at and do research on. We could look at this and say, all right, when did the first feather-like structure show up? In the group known as the theropods. And use that comparative biology to help us study dinosaur evolution. What group evolved towards or eventually into the birds? What ancestral group gave rise to the modern birds we have today? So this is why people will say dinosaurs aren't technically extinct, their ancestors, the birds, are still here. Not truly an accurate statement, because if we wanted to use the term dinosaur, let's go back to our paraphyletic grouping, these are dinosaurs right here. Birds would not be classified as a dinosaur. Birds would fall under the archaeosaur heading, but not technically the dinosaur heading. So, all right, so one example. Probably a more appropriate example, especially in light of today's environment, disease, the evolution of disease. How has disease evolved? How do viruses change and evolve over time? In the age of COVID-19, this is a huge, huge issue, something to seriously study and do more research on, because COVID-19 is not going to be the last one. There's going to be more. We already know there's others that will be evolving and changing and creating problems. We'll get into that more when we talk about viruses in our next unit or next chapter. So, but let's talk about this one called SIV. HIV is pretty much common knowledge for most part. SIV is the simian immunodeficiency virus. It's basically the primate version of HIV. So what we see is, based on the knowledge we have today, SIV has been present for millions of years. The molecular data tells us it's been around for a long time. Primates have been around for 50 plus million years. Viruses that infect primates have been around for who knows how many millions and millions of years. But it evolved, it changed, and it evolved and became this thing we call HIV, human immunodeficiency virus, somewhere around the 1940s. Now, it is very possible it could have been around before the 1940s, but we don't know if it was. Our knowledge says 1940s for sure, maybe earlier, hard to tell, but for sure 1940s we have recorded cases, diagnosed HIV cases in humans. When we look at HIV, there's a whole variety of strains out there. It's not all the same. 2 of the strains of HIV evolved from chimps and made the jump to humans. 1 of the strains of HIV evolved in gorillas and made the jump to humans. The other strains, not completely certain. There's evidence that certain primates most likely were the source of that virus before it jumped to humans. But understanding what strain of HIV you have, where it came from, helps us figure out how to treat this. If you don't know the cause of the problem, you can't really develop a good cure. It's why, again, with COVID, what's the source of COVID? What is the animal vector that transmitted COVID to humans? There is no evidence that COVID came from a laboratory. All of the molecular signatures and information that we have at this point says this came from a wild population. Leading contender, bats. Bats possibly into other animals, then the jump to humans. Again, we'll get into that later. So, all right, so in our next lecture, next part, we're going to talk more about disease evolution and how we use classification and systematics to study disease evolution and how it can benefit us especially in today's world.